Hello there, my name is Sakith. I'm in the sixth grade and I go to Drake Middle School. Now, my project is about a light tracking robot. My relevance of research is that a light tracking or light sensing robot can be used for the automation purpose, such as adjusting solar panels that are on top of the robot. It can do this by having two photoresistors, which will find where the sun is and move toward where the sun is. The solar panel will move with the robot since the solar panels, my bad, are on top of the robot. And thus they'll collect more energy than they would if the solar panels were just standing still. And then it'll create more energy. However, it is unknown whether changing the distance between the two photoresistors will actually affect the performance of the robot. Now you're probably wondering, what are photoresistors? So if I go to this illustration here, it shows two photoresistors, or the white arrows are pointing to two different photoresistors. Now, my problem is that we don't know if changing the distance between those two photoresistors will actually affect the performance of the robot. In my hypothesis, I believe that changing the distance between the two photoresistors will affect the performance of the robot. So what I did is I bought these materials, I assembled this robot, and I followed this procedure, and I did these tests in order to calculate the performance of this light tracking robot. So the two different tests I did, they are the 1 meter straight distance test and the 180-degree angular test. The first test, the 1 meter straight distance test, is where the robot has to go from start to finish. As you can see, the blue box is going to be the robot. It goes from here to here. And the distance between is 1 meter. Now, the second test that I did was the 180-degree angular test, in which the robot simply turned 180 degrees. Now, what I did was, between these tests, I changed the distance between the photoresistors from 0.5 inch to 1 inch to 1.5 inches. And I used, whenever the photoresistors were 1 inch apart, as the control, or what I'll be comparing the other results to. Now, the first figure is showing the results for the 1 meter straight distance test, and the X is the distance between the photoresistors in inches, and the Y is the time in seconds. Now, comparing 0.5 inches to 1 inches, or the control, it shows that you can choose that the 0.5 inches, whenever the photoresistors were 0.5 inches apart, was faster than the control. Now, whenever the photoresistors were 1.5 inches apart, though, there seems to be no difference actually in speed. They seem the same. Now we'll go to our second figure, which shows the 180-degree angular test. It has the same X and Y, and it's comparing 0.5 inches to the control, which is 1 inch. And it seems that the 0.5 inch is actually slower than the control. Now you're probably wondering, why is there no 1.5 inch in this graph? Well, that's because whenever the photoresistors were 1.5 inches apart, during this part of the test, it was actually unable to turn the full 180 degrees. And after analyzing all these results, looking at the graphs, I concluded that changing the distance between the two photoresistors affects the light tracking robot's performance in both the 1 meter straight distance test and the 180-degree angular test. I acknowledge Miss Middleton for providing me with the guidance and instructions that I needed to complete this poster and project.